Good morning, my lovely kiddos and my future mathematicians. Today we are going to be talking about 7.2, the properties of parallelograms. Now, I love parallelograms. Parallelograms have these 5 super cool rules that we are going to use to solve some problems today and in the future. So a parallelogram is a type of quadrilateral, meaning it has 4 sides. Okay, and we have 5 super cool rules that all parallelograms have. So let's jump into those. The first rule for parallelograms is that the opposite sides are congruent. Okay, so when we have a parallelogram, the sides that do not touch are congruent. So our left side and our right side are congruent, and our bottom and our top are congruent. Our second super cool rule is that opposite angles are congruent. Okay, so if we have a parallelogram, the angles that are not connected by a side are congruent. So our top left angle is congruent to our bottom right angle, and our bottom left angle is congruent to our top right angle. Our third super cool rule is that our opposite sides are parallel. So when we have a parallelogram, the sides that do not touch are also parallel, which we notate with these little arrows. So the left side is parallel to the right side, and the top is parallel to the bottom. Just like with tick marks, we have one parallel arrow here to denote that these two sides are parallel, and 2 parallel arrows to distinguish that the top and bottom are parallel. Okay, remember that parallel lines have the same slope. Our fourth super cool rule is that our consecutive angles are supplementary. Lots of vocab in this one, so let's break that down. Remember that consecutive angles, we talked about that way back in chapter 3, where our consecutive angles were on the interior of our 2 parallel lines and on the same side of the transversal. Okay, so if we have x and x, because we know that these 2 angles are congruent based on our second super cool rule, opposite angles are congruent, and we say that our bottom left corner and our top right corner are y and y, then we know that x plus y is equal to 180. So on the 2 sides right here and the 2 sides right here, they are supplementary, which means that they add to 180. And our fifth and final super cool rule about parallelograms is that the diagonals bisect each other. More vocab, so let's jump back into it. Okay, so if we have a parallelogram here, remember that the diagonals connect the angles that are not already connected by sides given in our shape. So our bottom left angle and our top right angle would have a diagonal connecting them. And our top left angle and our bottom right angle would have a diagonal connecting them as well. Now, our diagonals bisect each other, which means that this first diagonal is cutting our second diagonal into 2 congruent pieces, so they each get a tick mark. And our second diagonal here is cutting our first diagonal into 2 congruent pieces. Okay, so those are 5 super cool rules for parallelograms. Now let's jump into some problems. All right. In this first problem, we can see that we have a parallelogram, and they want us to find measure of angle C, the measure of angle B, and the measure of angle D. Okay, and then we're going to write down the super cool rule that lets us say what the measures of these angles are. So we know the measure of angle A, and we know on our second super cool rule that the opposite angles are congruent. So the angle's not touching angle A by a side. So angle A is connected to angle D and angle B. So angle C, remember, because opposite angles are congruent, would also be 51 degrees. Okay? And then we want to find angle B and angle D. Based on our fourth super cool rule, remember that sides, consecutive angles are supplementary, or they add to 180. So we could say that the measure of angle B plus that 51 degrees is equal to 180. And then we would just solve this like a regular algebra problem, subtract 51 once on each side of the equal sign, and get that the measure of angle B, I'm cutting into our slot for the measure of angle D, would be 129 degrees. And then we could use opposite angles, our second super cool rule again, to say that angle D is also 129 degrees. Okay, for number 2 here, we see another parallelogram, and we can use our fifth super cool rule that diagonals bisect each other to solve our problem to find M and to find K. So remember that diagonals bisect each other, so that means that both halves of each diagonal are congruent. So if we want to find M, we just have to set it equal to its other half of the diagonal. In this case, M is equal to 8. And that is already solved, so we don't have to move anything around. But in order to find K, we will have to do some algebra here. Remember that the two halves of the diagonal, we can go ahead and set them equal to each other. So we have K plus 4 is equal to 11. And then here's where we'll have to do some algebra here. We want to solve for K, so we have to get rid of this addition. So we're going to go ahead and subtract 4 once on each side of the equal sign. Positive 4 minus 4, those are going to cancel because they add to 0, leaving us with a positive 1K. We do not have to write the 1 to. And 11 minus 4 is 7. Okay, in our third example here, we want to find the length of GF. We want to find the measure of angle H, the measure of angle F, and the measure of angle G. So to find GF, we could use our first super cool rule that says that the opposite sides are congruent. GF is over here, so we are going to look at the side that is not touching GF or furthest from GF, which is HE. Since HE is 8 units long, GF must also be 8 units long because opposite sides are congruent. Next, we're going to go ahead and find angle H. Remember that when two consecutive angles here, they are supplementary. So we have whatever the measure of angle H is, plus that 60 degrees from angle E, and that is equal to 180. So solving this like an algebra problem, we're going to go ahead and subtract 60 once on each side of the equal sign. Positive 60 minus 60, those are going to cancel because they add to 0, leaving us with just the measure of angle H, and that is equal to 120 degrees. Okay, next we want to find angle F, which is opposite from angle H, or not touching angle H. So we could use our second super cool rule that opposite angles are congruent, and we know that angle F is also 120 degrees. Finally, we want to find the measure of angle G, which is opposite from the measure of angle E, which we know is 60 degrees. So we can again use our second super cool rule that opposite angles are congruent and say that the measure of angle G is also 60 degrees. Okay, and for our final problem here today, we want to go ahead and solve for X and Y. So we're going to solve for X First, we can see that 2x is one of our angles. So we're going to see if we could use our super cool rule number 2 that says opposite angles are congruent. And we see that we do have our opposite angle, or angle L, at 50 degrees. So since these are still congruent, they are still equal, we can set these two pieces equal to each other and then solve for x. To get rid of this multiplication of our coefficient of 2, we are going to have to divide by 2 once on each side of the equal sign. Multiply by 2, divide by 2. Those are going to cancel because they go to 1, leaving us with a positive 1x we do not have to write the 1 for. And 50 divided by 2, or half of 50, is 25. So x in this case is 25. And then to find y, we can use our first super cool rule that says that opposite sides are congruent. We see we have an 18 and a y plus 3 on our opposite sides, left and right. So we can, again, just set these two pieces equal to each other. Y plus 3 is equal to 18. And then solve like an Algebra 1 problem. To solve for y, we have to get rid of this addition. So we are going to subtract 3 once on each side of the equal sign. Plus 3 minus 3, those are going to go ahead and cancel because they add to 0, leaving us with a positive 1y that we don't have to write the 1 for. And then 18 minus 3 is 15 units.